The Collins class of 6 Australian-built diesel-electric submarines is operated by the Royal Australian Navy, RAN. The Collins class takes its name from Australian Vice Admiral John Augustine Collins. All 6 submarines are named after significant RAN personnel who distinguished themselves in action during World War II. The boats were the first submarines to be constructed in Australia, prompting widespread improvements in Australian industry. Planning for a new design to replace the RAN's Oberon-class submarines began in the late 1970s and early 1980s. Proposals were received from 7 companies, 2 were selected for a funded study to determine the winning design, which was announced in mid-1987. The submarines, enlarged versions of Swedish shipbuilder Kockums Västergötland class and originally referred to as the Type 471, were constructed between 1990 and 2003 in South Australia by the Australian Submarine Corporation, ASC. The submarines have been the subject of many incidents and technical problems since the design phase, including accusations of foul play and bias during the design selection, improper handling of design changes during construction, major capability deficiencies in the first submarines, and ongoing technical problems throughout the early life of the class. These problems have been compounded by the inability of the RAN to retain sufficient personnel to operate the submarines. By 2008, only 3 could be manned, and between 2009 and 2012, on average 2 or fewer were fully operational. The resulting negative press has led to a poor public perception of the Collins class. The Collins class was expected to be retired about 2026, however, the 2016 Defense White Paper extended this into the 2030s. The Collins class life will now be extended and will receive an unplanned capability upgrade, including but not limited to, sonar and communications. The Collins class will be replaced by the Future Submarine Program, C-1000, that is scheduled, according to the 2016 Defense White Paper, to begin entering service in the early 2030s with construction extending into the late 2040s to 2050. The Future Submarine Program will be based on the short-fin Barracuda design by French company DCNS with 12 submarines to be acquired that will be built in Australia. Development and design. The proposal for a new type of submarine to replace the Oberon class of diesel-electric submarines began in July 1978. When the RAN Director of Submarine Policy prepared a paper detailing the need to start considering a replacement for the aging Oberons. The paper also raised the suggestion that the majority of the submarines be constructed in Australia and that the number of submarines be increased beyond the 6 Oberons. Building the submarines in Australia was initially met with reactions predicting an impossible task because of the poor state of the Australian shipbuilding industry, and Australian industry in general. Although campaigning by several figures in Australian industry who thought it could be done came to the attention of those spearheading the project to design the Oberon-class replacement, and led to the view that it was both possible and feasible. The campaign to build submarines in Australia was also met with support from the Australian Labor Party and several trade unions. The proposal was accepted by the Defence Operational Requirements Committee in August 1978. And the project was given the procurement designation of C-1114. Approval for the development phase of the project was given in the 1981-82 federal budget. The RAN had 4 main requirements: that the submarines were tailored to operating conditions in the Australasian region, that they be equipped with a combat system advanced enough to promote a long service life, that appropriate and sustainable infrastructure be established in Australia to construct the boats, then provide maintenance and technical support for their operational lifespan, and that the submarines were capable of peacetime and emergency operations in addition to their hunter-killer role. 10 submarines were envisioned, a number which was revised to between 4 and 8 boats by the start of 1983, and later settled on the acquisition of 6 submarines, with the option to order 2 more. Requests for tenders. The development of the submarine commenced in May 1983, when the government released a request for tender and approached 7 of the world's 9 diesel-electric submarine manufacturers for submissions. The submissions would be narrowed down to 2 based on the provided information, with these undergoing a funded study to determine the winning design. Tendering companies had to demonstrate how Australian industries would be incorporated into the project, and that they were willing to establish an Australia-based consortium to construct the submarines. All 7 companies responded by the end of the year, the combined submissions totaling 4 tons, 9,000 pounds, of paper. Directions Techniques des Constructions Naval of France originally supplied a design modified from the Augusta class, but the Submission Review Board did not view this favorably, as the submarine was of the same vintage as the Oberons. Their submission was altered to a conventionally powered version of the Rubis-class nuclear submarine. The German companies Ingenieur Kontor Lübeck, IKL, and Hauldtswerke Deutsche Werft, HDW, collaborated to offer an enlarged version of the Type 209 submarine, designated the Type 2000. Submarines based on the Type 209 design had been exported to several nations, but were not operated by the German Navy. Thyssen Nordseewerke, another German company, offered their TR 1700 class submarine. Like the Type 209, the TR 1700 was an export-only submarine design. Cantieri Navali Riuniti of Italy proposed a design based on their Soro class submarine, scaled up by 25%. The age of the early 1970s design was a concern, and the proposal was withdrawn early in the process. The Dutch partnership of United Shipbuilder Bureaus and Rotterdamsche Drukdockmaatschappij submitted the Walrus class. Their offer was identical to that constructed for the Royal Netherlands Navy, minus the Dutch combat system. Swedish shipbuilder Kockums submitted the Type 471 design, an enlarged version of the Västergötland-class submarine operated by the Swedish Navy. The United Kingdom company Vickers Shipbuilding and Engineering offered a design referred to as the Type 2400, that later became the Upholder class. The review board concluded that the IKL/HDW Type 2000 was the best design offered. The Walrus class was rated as fair, while Kockums and Vickers' proposals were considered marginal contenders. However, none of the tenders completely matched the desired RAN specifications, and the 2 proposals selected would have to be redesigned during the funded study. The combat data system was procured separately to the submarine design. 14 companies were identified as capable of providing what the RAN wanted, from which 8 were approached in January 1983 with a separate request for tender. 5 responded, a consortium led by Rockwell International of the United States, Plessey of the United Kingdom, Signal of the Netherlands, Centre Alcatel of France, and a collaboration between the German Krupp Atlas Electronic and the British Ferranti. Each tender was required to offer a system with a distributed architecture, despite the absence of an accepted definition for distributed computing at that time, and had to show the cost of programming the software in Ada, although they could offer additional cost breakdowns for other programming languages. Funded studies. By May 1985, 3 months behind schedule, the review board narrowed the tenders down to 2 contenders in each group, IKL/HDW and Kockums for the submarine, Rockwell and Signal for the combat system. The Walrus and Type 2400 submarine designs were considered to be too expensive to manufacture because of inefficient building practices, while the combat data system tenders had been narrowed down by unjustified development risk in the Plessey and Krupp/Ferranti proposals, and the dual problems in the Centre Alcatel tender of excessive power usage and incompatibility with the proposed American weapons system. On May 9, the Australian Cabinet approved the selections for the funded studies and decided that 6 submarines would be built, with the option for 2 more, all in Australia. The companies were granted funding for project definition studies, from which the final selections would be made. Liaison teams were sent to each of the 4 companies to observe the development of the concepts presented in the initial proposals. As part of this process, the 2 submarine designers were required to establish a consortium with at least 50% Australian ownership. IKL/HDW joined with Eglo Engineering to form Australian Marine Systems, while Kockums, which had originally planned to work with Eglo, became part of a joint venture with the Australian branch of Chicago Bridge and Iron, Wormald International, and the Australian Industry Development Corporation to create the Australian Submarine Corporation. During the study, various accusations of foul play by or unsuitability of both submarine designers were made by Australian politicians and the media. These included claims that the similar left-wing political leanings of the Australian Labour Party, ALP, and the Swedish Social Democratic Party, both in power at the time, would lead to a pro-Kockums bias. Investigations into perceived coaching of IDL/HDW representatives and the questions to be asked at an ALP caucus briefing session on the project, and public emphasis on security incidents in both Sweden and West Germany. These incidents either lacked supporting evidence or were proven false, and were the result of the Liberal Party attempting to discredit the Labour government, or pro-British politicians and organisations who believed both submarines were inferior to the Vickers Type 2400 offering. The DIB report on the state of the Australian Defence Force was released in March 1986. It included advice that if the submarine project cost increased too much, the boat's capabilities should be scaled back to save money. Around the same time, Federal Treasurer Paul Keating began efforts to tighten fiscal policy and cut government spending across all portfolios. Consequently, despite his enthusiastic support for the project as a means to improve Australia's defence and industrial capabilities, Minister for Defence Kim Beazley advised the project heads that he would not be able to secure cabinet approval for construction of the submarines if the predicted cost started with a 4. Evaluation and final selection. The 4 tenders resulting from the study were submitted during October and November 1986. Although the IKL/HDW design was rated highest during the initial inspection, the evaluation team found that the German proposal was less attractive than previously thought. Although IKL/HDW claimed that their boat could meet the RAN's performance requirements, the evaluators concluded from the information provided that doing so would require the deactivation of all non-essential and some essential systems. Conversely, Kockums' proposal conceded that they did not meet the requirements, although evaluators found that the figures failed by only narrow margins, and believed that these were conservative. The evaluation team recalculated the capability statistics for both submarines to a common baseline, portraying the predicted Australian operating conditions, which generally saw Kockums' figures revised upwards, and those from IKL/HDW downwards. This resulted in growing support for the Type 471 bid, and outcries from the IKL and HDW groups, who questioned the validity of the recalculations and if the Australian evaluators had the experience to do this correctly. Analysis of the 2 combat system proposals saw Signal fall out of favour with the tender reviewers. This was primarily attributed to a cost-reducing redesign late in the process. The changes were not fully documented because of time constraints. Supporting documentation was further criticized by the reviewers for being vaguely worded and not using mil-spec terminology and standards. In addition, the system proposed by Rockwell appeared to have greater performance capabilities, and would be cheaper to implement. On May 18, 1987, the Australian Cabinet approved the final design, Kockums Type 471 submarine, fitted with the Rockwell system. The contract for construction of 6 submarines was signed on June 3 and valued at $3.9 billion in 1986 prices, with allowances for inflation and the changing value of the Australian dollar. The submarine acquisition project was at the time the most expensive project ever undertaken by the Australian Defence Force, but was unseated from this title by the Anzac-class frigate project a few years later. Construction. The Australian Submarine Corporation construction facility was established on previously undeveloped land on the bank of the Port River, at Osborne, South Australia. Work on the site began on June 29, 1987, and it was opened in November 1989. South Australia was selected as the site of the construction facility based on the proposed location of the facility and promises by the state government to help minimise any problems caused by workers' unions. The state's bid was aided by careful promotion to both Kockums and IKL/HDW during early in the project, and problems with the other states' proposals. Tasmania and Western Australia lacked the necessary industrial base. New South Wales could not decide on the location of the construction facility. Victoria's proposed site was poorly sited, and building in Liberal-led Queensland would have been politically unwise for the project when Labour was in power both federally and in all other states. Each submarine was constructed in 6 sections, each consisting of several subsections. One of the main criteria of the project was that Australian industries contribute to at least 60% of the work. By the conclusion of the project, 70% of the construction and 45% of the software preparation had been completed by Australian-owned companies. Work was subcontracted out to 426 companies across 12 countries, plus numerous subcontractors. In many cases, components for the first submarine were constructed by companies outside Australia, while those for the following 5 boats were replicated by an Australian-owned partner or subsidiary. The project prompted major increases in quality control standards across Australian industries. In 1980, only 35 Australian companies possessed the appropriate quality control certifications for defence projects, but by 1998 this had increased to over 1,500. Although the acquisition project organisers originally planned for the first submarine to be constructed overseas, the Cabinet decided as part of the project's approval that all 6 submarines would be built in Australia. The increases in construction time and cost from not building the lead ship in the winning designer's home shipyard was considered to be offset by the additional experience provided to Australian industries. Even so, 2 sections of the first submarine were constructed by Kockums shipyard in Malmö, Sweden. By the end of 1990, Chicago Bridge and Iron and Warmold International had both sold their shares in ASC. The shares were bought up by Kockums and the Australian Industry Development Corporation, with some of Kockums' shares then sold to James Hardie Industries to maintain an Australian majority ownership of the company. On April 5, 2000, the shares in ASC held by Kockums were bought out and the company was nationalised, despite a trend at the time to privatize government-owned companies. At the end of 2003, a contract to maintain the Collins class worth $3.5 billion over 25 years was awarded to ASC. As of April 1996, the option to order the 7th and 8th submarines was still under consideration, but was looked on unfavorably by the Department of Defence at the time, as the additional cost would require the diversion of funding from the Australian Army and Royal Australian Air Force, resulting in an imbalance in the capabilities of the Australian Defence Force. The option was cancelled outright by late 2001. Entry into service. The first submarine, HMAS Collins, was laid down in February 1990. Collins' launch was originally planned for 1994, but was later set for August 28, 1993. Although launched on schedule, she was not complete. The design of the submarine had not been finalized, important internal pipes and fittings were not installed, the components of the combat system had yet to be delivered, and some hull sections were actually sheets of timber painted black so the submarine would appear complete in photographs of the launching ceremony. Within weeks of the launch, Collins was removed from the water, and it was not until June 1994 that the submarine was completed. Progress on the other 5 submarines was delayed by the extra effort required to meet Collins' launching date and the subsequent work to complete her. Collins was not commissioned into the RAN until July 27, 1996, 18 months behind schedule, because of several delays and problems, most relating to the provision and installation of the combat data system software. Collins was not approved for operational deployments until 2000. The other 5 submarines were scheduled for completion at 12-month intervals. However, the series of defects and problems encountered during sea trials of the submarines, particularly Collins, resulted in the repeated diversion of resources from those still under construction, adding to delays. Consequently, delivery of the submarines ran significantly behind schedule. Submarines were presented to the RAN between 21 and 41 months late, and the entire class was not cleared for full operational service until March 2004, a year after the last boat was commissioned. These delays forced the RAN to keep several Oberon-class submarines and the submarine base HMAS Platypus in service beyond their planned decommissioning dates. Macintosh Prescott Report and Fast Track Program. Following his appointment as Minister for Defense following the 1998 federal election, John Moore decided that the only way to solve the various problems of the Collins class was for an independent report to be prepared on them. He appointed Malcolm Macintosh, chief executive of the XRO and an unofficial advisor to Moore, and John Prescott, a former BHP director, to investigate the project, uncover the problems with the submarines, and suggest ways of solving them. The report to the Minister for Defence on the Collins-class submarine and related matters, commonly referred to as the Macintosh-Prescott Report, was compiled in 10 weeks, and released on June 1, 1999. This report concluded that the Collins class was incapable of performing at the required level for military operations. Although the report highlighted several elements of the submarine design that performed to or beyond expectations, and acknowledged that many of the publicized problems had been or were in the process of being fixed, it presented the propulsion system, combat system, and excessive noise as ongoing problems across the class. After identifying the combat system as the central problem, Macintosh and Prescott recommended that it be scrapped entirely and replaced with a system based on commercially available equipment and software. They also claimed that these problems were caused by poor design and manufacture, inappropriate design requirements, deficiencies in the structure of the contract, particularly with regards to modifying the contract to meet changing requirements, and problems between the various parties involved in the construction of the submarines, with a lack of overall direction and conflicts of interest causing avoidable hostility and uncooperativeness. Despite the report being promoted by the government as groundbreaking, many people involved with the Collins class project later claimed that large sections of the report could have been copied from reports previously submitted by the RAN or ASC. The report, along with the planned December 2000 decommissioning of the final Oberon-class submarine, ODIMA, prompted the establishment of an $1 billion program to bring the 4th and 5th submarines, Dichaniux and Xian, up to operational standards, then retrofit the modifications to the other boats. Referred to as the Fast Track or Get Well program, the program also included solving the problems preventing various parties from cooperating fully, and improving the negative media coverage and public perception of the class by responding to criticism and providing more information to reporters. Problems during construction and trials. The Collins-class submarines experienced a wide range of problems during their construction and early service life. Many of these were attributed to the submarines being a new, untested design, and were successfully addressed as they were discovered. Most systems and features worked with few or no problems, while the boat's maximum speed, maneuverability, and low-speed submerged endurance were found to exceed specifications. The ship control system, which during development had been marked as a major potential problem, functioned beyond positive expectation. For example, the autopilot, which aboard Collins was nicknamed Sven, was found to be better at maintaining depth during snorting than most helmsmen. However, problems with the combat system, excessive noise, and engine breakdowns were recurring and appeared across the entire class. These and other shortcomings were often made harder to solve by disagreements between COCOMs, ASC, Rockwell, the RAN, and the Australian government over the nature of problems, their causes, and who was responsible for solving them. Media reporting of the problems during the mid-1990s was often negative and exaggerated, creating poor public perception. This was aided by politicians, who used the shortcomings to politically attack the Labour Party and Kim Beazley, particularly after Labour was defeated by the Liberal National Coalition in the 1996 federal election, and Beazley became leader of the opposition. During the mid-1990s, it was recommended on several occasions that the submarine project be abandoned, and the completed submarines and incomplete hulls be broken up for scrap. Following the Macintosh-Prescott report, which indicated the long-term faults with the class that still required solving, successful efforts were made to bring the submarines to operational standard. As part of this, a public relations plan was implemented to provide up-to-date information on the submarines to the media, to improve the public perception of the class by providing factual information on the status of the project and responding to queries and incidents. This same period saw the dispelling of the idea, widely held within the RAN, that the Collins-class boats would be like any other vessel previously ordered by the RAN, in service with another navy, well tested, and with all the problems solved before they entered Australian hands. The RAN began to realize that as the parent navy for the class, they had a greater responsibility than normal in ensuring that the boats were at an operational standard. Welding of Collins. During assembly of Collins' bow section in Sweden, multiple defects in the hull welding were discovered. Different reasons were given by different parties for the problems. The steel alloy used for the hull required different welding techniques to those normally used by Kockums. The Swedish Navy always requested partial penetration welds for their submarines, while the RAN wanted full penetration welding, but had not made this clear. Delays in delivering the steel plates to Kockums resulted in rushed work and a resulting drop in quality. Kockums engineers proposed that the section be kept in Sweden for repairs, but to minimize delays it was accepted as is, with repairs attempted at ASC during full assembly of the first boat. However, when Collins returned to the ASC facility in April 2001 for a year-long maintenance docking, multiple welding defects were found in the bow and escape tower sections of the submarine, the two sections constructed by Kockums, while almost no problems were found in the welding of the 4 Australian-built sections. Repairing these welds quadrupled the time Collins spent in dock. Noise signature. The noise made by the submarines, which compromised their ability to stay hidden, was another major problem with the design. In the original requisition, the RAN guidelines for the noise signature of the new submarines were vague, for example, asking that they be twice as quiet as the Oberons. Expectations and operational requirements also changed between the 1987 contract signing and when the submarines began operating in the late 1990s. The major element of the noise signature for the Oberon class was machinery noise transmitted through the hull. This was successfully avoided during construction of the Collins class by mounting machinery on platforms isolated from the hull. Noise testing during 1996 and 1997 found that the hydrodynamic noise signature, the noise made by a submarine passing through the water, was excessive, particularly at high speed. The shape of the hull was the main cause, although a scale model of the design had been tested during the funded study and was found to have a minimal signature. The hull shape was changed after the contract was signed, primarily by a 2-meter (6.6 feet) lengthening of the submarine and a redesign of the bow dome to accommodate the larger-than-expected main sonar and reduce its blind spot, the baffles. The design had not been retested, as who would pay for this could not be agreed on. Propeller cavitation, caused by water flow over control surfaces onto the propeller at certain speeds, was the other main noisemaker. Cavitation had not been a problem with earlier Swedish submarine designs or during early testing of the Type 471 design, but the propeller had to be redesigned late in the process to provide more power, and like the redesigned hull, was not retested. During the years 2000, an unusual meeting took place with a next-door neighbor, Francis Frank Smith, of the then HMAS Sterling Naval Base commander. He was an aircraft maintenance engineer, originally trained at Government Aircraft Factory's Fisherman's Bend, who had been aware of the fluid dynamics issues of the Collins class for some time, purely by interest and observation on television. After a lengthy discussion, he was invited to discuss and demonstrate where possible, his observations at the Sterling Naval Base with Navy and DSTO staff who were there at that time as part of an investigative group. He showed on a whiteboard the aerofoil issue with the dorsal sail conning tower structure, showing that the chord ratio, length to width, was too short and that severe turbulence/cavitation would be generated by such a design. This was demonstrated again on the whiteboard using aircraft aerofoil wing shapes as a basis for the discussion. That the turbulence/cavitation generated would, by natural rearward flow, move down the rear upper surface deck of the hull and be drawn into the propeller. He was also able to demonstrate that the design of the bow section would not pass a flow test for generated turbulence/cavitation, with the change in shape from circular bow section to long hull, being ill-conceived. He made several recommendations during the lecture that would be cost-effective and possible. 1. To lengthen and taper the dorsal fin and create a more streamlined integration of the dorsal to flat upper hull deck section. And 2. To fill in the hollow section of hull aft of the bow curvature. Both these could be achieved with carbon fiber or fiberglass covers, as no load-bearing strength would be required. Subsequent studies by the Defense Science and Technology Organization showed that the submarine's hull shape, particularly the redesigned sonar dome, the fin, and the rear of the submarine, focused the displaced water into two turbulent streams. When the 7 propeller blades hit these streams, the propeller's vibration was increased, causing cavitation. These problems were fixed by modifying the casing of the submarine with fiberglass fairings. Propulsion System. During trials of the first submarines, the propulsion system was found to be prone to failure for a variety of reasons. Most failures were attributed to the 15-tank diesel fuel system. The tanks were designed to fill with salt water as they were emptied to maintain neutral buoyancy, but water would regularly enter the engines due to a combination of poor design, gravity separation of the fuel and water being insufficient, and operator error resulting from poor training. Problems were also caused by bacterial contamination of the diesel fuel, which, along with the salt water, would cause the fuel pumps to rust and other components to seize. The fuel-related issues were solved by installing coalescers, improving training and operational procedures, and adding biocides to the fuel. Propeller shaft seals were a significant problem on Collins and Farncombe. Although designed to allow for a leak of 10 liters, 2.2 imp gal, 2.6 US gal, per hour, during trials it was found that the seals would regularly misalign and allow hundreds of liters per hour into the boat. During one deep diving test, the flow rate was measured at approximately 1000 liters, 220 imp gal, 260 US gal, a minute. ASCCL.
Please subscribe and thanks for watching.